right. Well, welcome to class. Happy Wednesday. Go ahead and take out your notebook. Start on the warm up. I'll give you a few seconds to do this. You need to recall this for today's lesson. And when you're done, I'll go ahead and review this. So take some time to do that now. All right. So I'm going to go ahead and get started here reviewing the warm up. I'm going to do number one. And so what it's asking you to do is distribute this negative into this polynomial. So we have negative times the quantity 2x plus 3 minus 5x. Remember, when there is no number there, there's an imaginary 1. It's just kind of incognito. It's like an undercover spy agent, right? So we have this negative 1 that we're going to distribute into all the terms of this polynomial written in parentheses here. So we have to do negative 1 times 2x gives us negative 2x. Negative 1 times positive 3 gives us negative 3. And negative 1 times negative 5x gives us positive 5x. And it asks you to also collect like terms. So we can combine like terms. Negative 2 positive 5x gives us a 3x. And I just realized I wrote an x in there when it shouldn't have been. All right. So it should be negative 2x minus 3 plus 5x. Then we have negative 2x plus 5x is 3x minus 3. So this is your answer. You can collect like terms first and then distribute. So if you did that, you would have a negative 1, and then you'd have a 2x minus 5x, which is a negative 3x plus 3. And when you distribute the negative 1, you get this same answer, 3x minus 3. So either way. All right, let's look at number 2. Number 2 now. We are multiplying negative 2 by 3x plus 2x squared minus 5x plus 4x squared minus 12 plus 3x squared minus 7. All right, I'm going to do myself a favor, and I'm going to collect like terms before I multiply, just so I can have less to multiply. So I'm going to collect like terms here. So I have uh, 2x squared, 4x squared, and 3x squared. So 2 plus 4 is 6, 6 plus 3 is 9. So I have negative 2 times a 9x squared. Then I have my x's. I have 3, negative 5 gives me negative 2x. And then I have my numbers, negative 12, negative 7 gives me negative 19. So now what I need to do is distribute this negative 2 in. And so I have negative 2 times 9x squared gives me negative 18x squared. Negative 2 times negative 2x is positive 4x. And then negative 2 times negative 19 is positive 38. So this is distributed and collected in like terms. All right, so we're going to use that strategy today. Now, if you did distribute the negative 2 by everything, collect like terms, you should get the same answer. I won't go through, I'll spare you that expense, but you'll get the same answer. All right, so here's today's essential question. How do you add, subtract, and multiply polynomials? So we're going to look at this today. The past 2 days, we were able to write a polynomial in standard form, identify the leading coefficient, identify the highest degree of that polynomial. Then the next day, we identify kind of what the ends of the graphs look like. Remember, if it was negative, it did the inverse. But if it was odd, it went down on the left side and up on the right side. If it was even, it went up on both sides. But remember, the inverse flipped it. So then the inverse of an even, they would go down. The inverse of an odd, it would go up on the left and down on the right. So today what we're going to do is, well, what if you have multiple polynomials and you need to add them together, you need to subtract them, or you need to multiply? I'll be honest with you, the adding part is very elementary. It's just a matter of you collect like terms properly. The subtracting part, as long as you do what we did here in the warm-up correctly, you're not going to have a problem. These are very straightforward. But the polynomial part can be a little tricky, but we'll go over some examples and you'll do great. All right, so let's go this first example here. This first example, we are going to add these two polynomials. We have 6x cubed plus 4x plus x squared minus 7. And we're going to add another polynomial to it. 2x squared minus 8x squared plus 3. And I just realized that is supposed to be a cubed. That was a misprint on my part. Again, let's do this example. 6x cubed plus 4x plus x squared minus 7 plus 2x cubed minus 8x squared plus 3. So if we do this correctly, we're just going to add them. There's nothing to do, so we can actually take away the parentheses and just collect like terms. So I'm going to rewrite this without the parentheses, just because when you multiply by a positive 1, it doesn't change anything. So when you're adding two polynomials, all you're doing is collecting like terms. So we've done this already, so I'm not going to spend a lot of time, but your highest value goes first, so the x cubed, and we have 6 and 2, so we have 8x cubed. You have your squares. You have 1 and negative 8, so you have negative 7x squared. Then you have your x values. You just have the 4. So we have plus 4x. And then you have your numbers, negative 7 and positive 3, which is negative 4. So this is a two polynomials added together gets you a new polynomial. That'll always happen. When you have a polynomial, you're going to add another polynomial to it. You're just left with a different looking polynomial. So it has to be in standard form, written in the highest degree first down, and then the leading coefficient's 8. So what would this graph look like? It would be down on the left side. It would be up on the right side. And the most number of turns it could have is 2. So the graph would look something like this. 1 turn, 2 turns. It would be left going down. On the right, it would be going up. Now, it's probably some extreme sharpness going. What these cause in here is what this change would happen. How sharp these turns are, how big and tall they are. All that information plays in here, but we're not worried about that right now. So let's go to the next example. Next example is subtracting. Now, I purposefully put things in here because I want you to keep track of like terms. You can only collect like terms when they match perfectly. So an x squared y squared has to match up with another x squared y squared. First thing I'm going to do is distribute this negative. So I have a negative here. I need to distribute that to all the terms, just like we did in the warm-up. So I'm left with 3x squared y squared plus 2xy squared plus 6x squared minus 2x squared y squared minus 3xy squared plus 2x squared, because the negative times a negative. So now all I need to do is collect like terms. So I need to identify the x squared y squareds, and there's 2 of them, a 3 and a negative 2. So I'm left with x squared y squared, one of them. Next, I want to identify the xy squared. Xy squared, I have 2 and negative 3, which is negative 1 xy squared. And then I have my regular x squareds. 6 plus 2 gives me 8x squared. So this is a new polynomial with the highest degree term first. All right. Now I would like you to try these 2 problems. Do the same thing we just did. Take a moment, add the 2 polynomials together, then subtract, and let's see what you come up with. All right, we're going to look at the first one here. So the first one is really, we could just remove the parentheses. So I'm going to collect like terms. I know I have an a cubed. I know I have a squareds. I know I have a's. And I have numbers. And there's just one a to the fourth. So I'm going to rewrite this as 4a to the fourth. And then I have negative 6 plus 5 gives me negative a cubed. I have negative 3 plus 7 gives me positive 4a squared. And then 1 plus 2 gives me 3a. And then 1 minus 2 gives me negative 1. So this is my new polynomial written in standard form, where a to the fourth is the largest degreed term. Positive 4 is my leading coefficient. So when I added these two, I just came up with a new polynomial. Now, when you did the next one, a squared, b squared match up. The a b squareds need to match up. Careful, they weren't written in the same order. And then my a squared b need to match up. But remember, I'm distributing a negative here. So I have 2 minus 3 is a negative a squared b squared, because 2 minus 3. Then I have a 5 plus 9, because it's a negative times a negative. 5 plus 9 gives me positive 4a squared b. And then I have a 3 minus 7 gives me a negative 4ab squared. So this is my new polynomial written in standard form. So hopefully you got those. If not, fix your error. Next, we want to do the examples. What happens when you multiply? Now, really quick, if you look back at Algebra 1, we had x plus 1 times x plus 3. Right? We did the FOIL method, right? First, inner, outer, last, and we got x squared plus x plus 3x plus 3, and we simplified that to x squared plus 4x plus 3. We just did that in this last quadratic section, right? Writing it in standard form. So this is factored form here, and this is standard form here. Where the same concept needs to happen here. You have to take this, and each term in this parentheses needs to multiply by everything in the other one. So let me write it in a different color so it'll make sense. So 2m plus 5 times 3m squared minus 4m plus 2. So I need to multiply everything inside this second parentheses by 2m. But I also need to multiply everything in this parentheses by 5. So I'm going to end up with 6 different terms that I'll then have to simplify to. So I'm going to write this out so you can see it. 3m squared multiplied by 2m plus 2m multiplied by negative 4m. That's that second one. And then 2m again multiplied by this positive 2. And then on the flip side, I have this plus 5 multiplied by 3m squared again, because I have to do everything in there twice because there's 2 terms. Plus 5 again times the negative 4m this time. plus 5 times the positive 2. So I'm going to write this all out so that I don't make any mistakes. Now I just need to multiply. 2 times 3 is 6. So I get my 6. And then m times m squared is m cubed. When you multiply like bases, you add the powers. So since it's m to the 1 times m squared, it's 1 plus 2 is 3. Now I have positive 2 times negative 4 gives me negative 8. M times m is m squared. And then 2m times 2 gives me positive 4m. Then I have this 5 times 3 is 15m squared. 5 times negative 4 gives me negative 20m. And 5 times 2 gives me positive 10. So notice, I wrote these in colors on purpose. The two m's, when you multiplied 3m squared minus 4m plus 2, produced the 6m cubed minus 8m squared plus 4m. And then the positive 5 multiplied by that polynomial produced the 15m squared minus 20m plus 10. So now the only thing you have to do is collect like terms. So if you take this, the highest degree term is 6m cubed. And the squares, we have negative 8 and positive 15. So we have positive 7m squared. The m's, we have 4 and negative 20. So we have negative 16m. And then we have a plus 10. So when you multiply those two polynomials, you get a new polynomial. Now notice when you added or subtracted, the degree didn't change. The highest degree never changed. But here it does. You have the possibility of your highest degree changing. So now we have a cube instead of a square. So when you have a linear polynomial multiplied by a quadratic, you get a cubed polynomial, a cubic. So again, if we look at the graph, it's positive and it's odd. So it goes down to the left, up to the right, and the most number of turns it could have is 2. So this is just a rough sketch of what it could look like. Now, what this part does to it down here afterwards drastically changes what this middle could look like. But I do know the max number of turns it could have is 2. And I know it goes down to the left and up to the right. All right, so let's look at another example. Now, you can have multiple polynomials multiplied together. There's no end to this. And you just take it one step at a time. So the only thing I'm going to look at is the first two. I'm going to do that first, and then I'm going to multiply the other way. Just as if it said 2 times 3 times 7, you're going to do the 2 times 3 first, and whatever you get, you're going to multiply it by 7. The same thing in polynomials. You take 2 at a time, combine them, and then just keep multiplying, however many you have to do. So we're just going to look at this. This is just basic FOIL. So we're going to do m times m gives me m squared. N times n gives me n squared. Then I have minus 2mn plus 1mn minus 2. So when I multiply those, m times m gives me m squared. N times n gives me n squared. Then I have a positive 1 and a negative 2 of the mn's. And then positive 1 times negative 2 gets me the negative 2. And then you still have that mn plus 4 to multiply for. to multiply by. But before you do, I would highly recommend simplifying if you can. That way you have one less thing to multiply by. So by doing that, you're going to be left with m squared n squared minus mn minus 2 multiplied by mn plus 4. Now we're going to do this just like we did on the last one. We're going to take each term and multiply it by the other one. So I'm going to do this one in red, this one in blue, and this one in green. So I have m squared n squared multiplied by that first term, mn. Then I have a plus m squared, oops, did it in the wrong color. M squared n squared multiplied by 4. Then I have my negative mn times my mn in the second one. Then I have my negative mn times my positive 4. One more to go with the green. I have a negative 2 multiplied by the mn. And then I have a negative 2 multiplied by the positive 4. So this isn't super complicated. It's just tedious. You got to take one term at a time. So m squared times m gets me m cubed. So I have m cubed. And then n squared times n gets me n cubed. Then I have a plus 4m squared n squared. And then a negative times a positive is going to give me a negative. M times m is m squared. N times n is n squared. And then minus 4mn. And then I have a negative 2 times mn gives me negative 2mn. And then negative 2 times positive 4 gives me negative 8. So I'm just going to collect like terms. I have these two I can combine. Then I have these two that I can combine. So I have the 4m squared n squared minus m squared n squared. So I have 3 of them. So I'm going to rewrite this. I'm going to rewrite this as a simplified term. I have m cubed n cubed plus 3 because I have 4 minus 1, m squared n squared. And then a minus 4 minus 2 gives me a minus 6. Minus 6mn. And then a minus 8. So now this is the new polynomial written in standard form. All right, so what I'd like you to do now is I want you to try these on your own. So you're going to take, just like we did in the examples, I want you to multiply these polynomials. Ready, go. All right, welcome back. Let's take this first one, and I'm going to do this one in green and this one in blue. I want you to check your work here. So by doing this, you have 6n squared that I'm going to multiply by n squared. And then I'm going to have the plus 6n squared multiplied by the n. And then I'm going to have the plus 6n squared multiplied by the 3. Then I have my negative 7 multiplied by the n squared. And then I have my negative 7 multiplied by the n. And my negative 7 multiplied by the 3. So when I simplify this, 6 times 1 gives me the 6. N squared times n squared gives me n to the 4th, because when you multiply like bases, you add the powers. Then I have 6 times 1 again, gives me 6. N squared times n gives me n cubed. And then 6 times 3 gives me 18 n squared minus 7n squared minus 7n. Oops, these should be blue. That way it's not confusing. Let me rewrite these in blue. Minus 7n squared minus 7n minus 21, because we have 7 times 3. Negative 7 times 3. All right, so now we need to collect like terms. And it looks like we just have these two right here to collect. So when you're done collecting those, you have 6n to the 4th plus 6n cubed plus 11n squared, because 18 minus 7 minus 7n minus 21. So this is the simplified polynomial in standard form when you multiply those two polynomials. All right, so check your work. Make sure that's what you got. And what we're going to do now is go over and do the second one. Check your work again. Again, I want to do these first two first. This is just foiling. So I have m times m squared gives me m cubed. N times n is n squared. Then I have negative mn, positive m squared n, and then minus 1. Now there are no like terms you can combine here, so you do have to multiply this whole thing by the next one. And what I'm going to do is I'm going to flip the colors over here so it's easier to see. So I have this m cubed n squared multiplied by m n squared. And then I have the negative mn multiplied by the mn squared. And then I have the m squared n multiplied by the mn squared. And then I have the negative 1 multiplied by the mn squared. Okay? So you just take one term at a time. Don't get overwhelmed. Just take one term at a time and keep going. Now I'm going to do the red one. So I have the positive m cubed n squared multiplied by the negative 2. Sorry, by the positive 2. Then I have my negative mn multiplied by the positive 2. non-color. And then the plus m squared n multiplied by the positive 2. And then the negative 1 multiplied by the positive 2. So let's simplify this now. So I get m cubed times m is m to the fourth. Sorry, you couldn't see that last part. There you go. So make sure you have that. Now, what we're going to do is simplify this. Let me zoom out a little bit. It will help everybody out. So I have m cubed times m is m to the fourth. N squared times n squared is n to the fourth. Then I have a negative. M times m is m squared. N times n is n cubed. Then I have a m squared times m is a m cubed. N times n is n cubed. Then I have a negative 1 of that, so I just have negative m n squared. Now I'm going to multiply that 2, so I have a plus, or I'm going to change colors here so you don't get confused. So plus 2m cubed n squared minus 2mn plus 2m squared n minus 2. So let's see which like terms we collect. So if I look at the red ones, there are no m cubed n squares, so I can't combine that. There are no mn's, but there is an m. No, there is no. Nope, no m squared n. So this is your polynomial. So if you're going to write this in standard form, you're going to go m to the fourth, n to the fourth. Then you usually start with your m's. So you're going to go plus m cubed n cubed plus 2m cubed n squared minus m squared n cubed. And then we have a plus 2m squared n minus m n squared minus 2mn minus 2. Okay? So usually what you'll do is you take the highest term possible, which is the fourth power, and then you just keep going down 3, 2, 1. Now your question might be, does it matter in this term right here and these terms right here, which one goes first? You usually put it in alphabetical order. So your m, since your m is a 3 and your n is a 2, and it's the other way around the other way, usually alphabetical order goes first. So you would put the m cubed n squared before the m squared n cubed. So if you remember that, it's fine. Now on the test, I'll accept this answer right up here. But if you are going to be technical and move on to higher division math classes, you will want to know what standard form is in this polynomial, and I just wrote it here for you. All right, so what you have time now is to work on homework. You're going to do these. You're going to add or subtract polynomials, and you're going to multiply the polynomials. So that is your